And this is Olga Media from You to You. As you know, Olga Media supports technology, culture, and people. And at UP conference, I met another wonderful company, ALGO-LOGIC.
That's right, algorithms and logic.
Oh, algorithms. So yeah, and you have to watch out because CEO has PhD from Stanford.
So yeah, right. So our company was founded as a startup out of Stanford University. Is that I was a professor at Stanford running a program called the NetFPGA. And from 2007 to 2009, we had about 1,000 users that were building research prototypes on this FPGA platform for networking.
Okay.
So we're building internet routers and switches and firewalls and gateways. But one of the first open flow switches was called Ethane, and with Martin Casado and other graduate students, Jinyang Liu at Stanford University, we published papers on how to prototype these first SDN switches and with hardware. We did it on the NetFPGA platform. But we had all these research projects. We also had a few commercial projects that benefited from using FPGA hardware to do networking. And that's when we started the company in 2009, ALGO-LOGIC, to service those commercial customers that were building needed high-performance networking.
And so all those names like GDV, what this stands for?
Okay, so gateway-defined networking, or GDN,
GDN, yes.
is a variation of like software-defined networking. And so in software-defined networking, you have to split the world into software controllers and switches, and so Ethernet switches. And pretty much the data path either goes through the fast path in the ASIC or it goes to the very, very slow path in software. And so the first packet gets delayed quite a bit as it goes to the SDN software controller. But then the rest of the packets either go through a network function virtualization, NFV, or they go through a ASIC switch. So gateway-defined networking is this in between. We use field programmable gate arrays, or FPGAs, to process packets. And we can use FPGAs to process their payload and the header, transform the packets, and implement arbitrary data processing functions in hardware.
And that's for all kinds of data?
So we focus on applications that need latency. And so, for example, in stock trading, we make stock trading systems that can process market data and place stock market orders very quickly.
Okay.
And so, high-frequency traders need microsecond speed transactions. And so we've been building products to service those microsecond transactions for years.
And beside this three letters abbreviations, you just named few NFV, and that's a company also under this name. If I
well, so NFV or network function virtualization is something that is often implemented in software.
Right.
But in our variation is that we take our network functions and put them into gateware.
Okay.
And so by doing a function with network function virtualization, putting it in gateware, is that our latency is about a microsecond instead of tens of microseconds it might be in a software implementation.
And then you have another abbreviation, it's KVC? No,
KVS.
KVS, yes.
Yeah, so for key value search is that
key value search, yes.
Is that when you want to look up data, you want to make an association. You need somebody's phone number. You have their name, but you need their number.
Right.
Or you have an IP address and you need their MAC address.
Right.
Or you have a data block and you need to know if it's duplicated or not in your network. So a key value store lets you instantly look up that key in a database and get you a value back.
Right.
And so there's a lot of implementations like memcached, memory cache, which stores those values in memory. So Facebook, for example, builds their data center services out of memcached.
Right.
And so, and it's basically a key value store. And so we applied our gateway technology to build a much faster key value store so that it can store and retrieve these keys in about a microsecond off the network instead of what is usually tens of microseconds.
So you came for UP conference to give press release.
Well, there was a press release, but we came to announce to the world about this key value store in Gateware. And this combined with our load balancing switch, which is also in Gateware, can handle this 150 million I/O operations per second. And a single little card, which is about the size of a GPU or smaller. And it uses just a little bit of power, tens of watts, and it has 10 gig or 40 gig or 100 gig Ethernet ports on the back. And so it's really easy to integrate this in the data centers.
Right.
And so we came here to let people know that this is an option. It's a very inexpensive option. It's a very scalable option to make data centers go a lot faster.
Now, do you have office here in Stanford somewhere or nearby?
Yeah, so our first office was in downtown Palo Alto, and so we were right off University Avenue on Lytton Avenue. We grew out of that office. We ran out of space, and we moved down to Santa Clara, and also in Silicon Valley. And so right now we're right next to NVIDIA. We're a block away, and we're 3 blocks south of Intel.
I bet they need that too for their computer games.
Yeah, certainly for NVIDIA is that the GPU has really advanced the world of making video games, as like 3D video games look beautiful and go fast. And so our spin is that GPUs are fantastic for doing vector processing, but FPGAs are really good for doing small transaction processing. And so we kind of see a world where CPUs and GPUs and FPGAs all live together in this heterogeneous computing environment. So that's the world that we're trying to build.
Now, to have those device GPU, you build it here in California, or you have to outsource it? And
so these cards, the cards that we don't have a proprietary platform. It's an open platform.
oh, okay.
And
Make
so
it cheaper for anyone and easier to use.
That's right. So people can buy standard PC servers,
Right.
and they can buy standard FPGA cards. And we partner with about half dozen vendors,
Right.
and we build applications that run on these cards.
Okay.
So it's very easy to assemble and build scalable systems with these cards.
So any cards will do.
And any cards will do. Is that, again, we have about a half dozen partners today that we work with, and we're growing that list. Our objective is to have almost any off-the-shelf FPGA card we have application support for.
So while you saying that you covered usually like trading companies would be interesting in this solution, do you offer that for many other companies as well? Who your target companies will be?
Right. So in the stock markets is that we have FPGA cards that are deployed in all the U.S. markets.
Right.
So on NASDAQ and on NYSE. In the European market, we have brokers that use this to connect to the London Stock Exchange. In Europe, at other locations in Europe, we have FPGA cards in the co-location facilities, and we're even expanding now into doing the Asian markets as well.
All right. So you're making it faster and easier.
We make it faster and easier to do stock trading, and so by having these FPGA cards in a co-location facility, these are really the fastest way to do stock trading, is that they just consistently can't be beat by software.
Now, if people will say, yeah, faster is good, but how about security during that faster movements of data? Do you offer that, or we go to third parties?
Yeah, so for doing, especially in the stock market, it's really critical to have things be safe. And given that stock trades now are going so fast, that the problem is it's very difficult to be compliant. And so there was a flash crash that happened a couple of years ago, where a bad order went into the stock exchange, and it caused the market to fall by almost 10%
Right.
within minutes. And so the SEC in the United States put in a law that mandated that there be compliance checks performed on all these stock market orders as they pass from a broker-dealer or a trader into the exchange. So ALGO-LOGIC builds a compliance module that checks all the stock market orders as they pass through using FPGA hardware. So it's done in gateware on an FPGA card, and it takes about a microsecond. So it's 1/1,000,000 of a second. It verifies that that order on about 15 different criteria, 20 criteria for some companies that have more specific checks, are valid and they're compliant and that they're safe to go into the stock market. So we believe in security, and we enforce these compliance rules with our stock market trading applications.
Is your company private?
The company is private, and so the company is a C corporation in California. We were formed initially as an LLC back in 2009, converted to a C corporation, and we still operate as a private company.
During those years, 5 years, that's a lot of years to survive. How did you able to handle that?
Yeah, the company's grown. Is that we had customers from the day that we started, and we've been growing in revenue and every year since we've been in operation. The company is net profitable, and so for startup companies, very few companies.
Yeah, in a short period of time.
Right, and that's without outside investment.
That's very good. So, in terms of your education, you have premier education, one of the premier education, Stanford, PhD in mechanical, electrical engineering.
Right, so I taught at Stanford as the NET FPGA program from 2007 to 2009. So I was a consulting associate professor there, also a visiting associate professor at Stanford.
Right.
My PhD I did at University of Illinois at Urbana-Champaign, and so I'm an electrical engineer from Urbana-Champaign.
Where is that?
It's in the middle of the country. Is that the University of Illinois is exactly halfway between the West Coast and the East Coast, and it's a very big engineering school, and so the Illini, a large contingency here in Silicon Valley.
That's a lot of algorithms.
Yeah, is that we do a lot of algorithms. We have about a dozen different algorithms that we've put into FPGA hardware, and we have all these algorithms that are up and running as gateware applications.
Did you come up with this abbreviation GDN and KVS yourself, or company-wise, or
well, the
industry?
Yeah, the industry is really pushed. I think Stanford really advanced the world of software-defined networking. Martin Casado and others kind of created this market for software-defined networks. In gateware-defined networks, there's just a twist of this, but it's different because instead of trying to force everything to run into software,
right,
is that we leverage this FPGA technology so that we can still get ASIC speed packet processing, but we can also fully reprogram all the functions that are there.
Wow, that's very impressive that with GDN and KVS you have very fast, reliable data transfer.
Mm-hmm.
Milliseconds, you said, or microseconds?
Microseconds.
Microseconds. Yeah, that's a lot of data, lots of numbers and transitions as well, especially in trade industry.
Mm-hmm.
Great. So, what would you wish to our viewers and listeners?
So I hope that the community can be open to this idea of heterogeneous computing. Is that in the past it's been very focused on doing things in software, where we only think about how do we compile things to run sequentially on a microprocessor. Is that there's a whole other world. And so the GPU, for example, opened up the idea of doing vector processing to make video games go faster and to make supercomputing applications go faster. The FPGA opens another space, which is the space of how do we make logic state machines operate very quickly and with deterministic latency. And so I just hope the community keeps their head open to, in the world of compute, there's a lot more than sequential processing, that there's this whole world of parallel computation, and FPGAs and gateware provide a good way of doing that.
Oh, thank you for doing it, because it's definitely make my life easier, because we don't want to wait for anything to come in too late, right?
Right.
No,
Internet users don't like delay, and stock traders don't like delay, and so we think gateware can help get that latency out of the network.
That's very good. Thank you for making it happen and continue to solve our technology problems in our ways.
Okay, thank you.
Thank you.
Okay.